Hello friends, today we are going to learn about some fault finding and diagnosis methods in refrigerators, and today's symptom is frost-free refrigerator doesn't cool, compressor and light do not operate. So this is the symptom which the customer has given us. So the customer feedback is there is no cooling in the refrigerator, the light doesn't glow inside the refrigerator and the food gets spoiled. For solving any problem or for analyzing, what we need to do is to ask some basic questions to the customers. Like in this case, you can ask the customer whether they have checked the refrigerator with some other socket, some other power input socket, so that we can rule out the possibility of any problem in the power socket. We can ask the customer whether they have thought of installing any stabilizer if there is any voltage fluctuation in their area. We can also ask the customer whether there is no cooling in the entire refrigerator or only there is no cooling in the refrigerator section and the freezer section is cooling, so that we can understand whether the compressor is running or whether the problem is only with the refrigerator section, so we know whether the problem is due to air ducting and other reasons. So one more question that we can ask them is, while pressing and releasing the door switch, does the light glow inside the refrigerator? Light glowing inside the refrigerator while pressing the door switch would be an indication that the power input circuit is complete and it's okay. So we have to ask one more question to the customer, that is whether they can hear the humming sound of the compressor, so we know that the compressor is running. Or was there any sound of a sparking or electrical spark or some kind of electrical short circuit which must have happened in their home before this situation arose. So we have put down all the possible causes in a dot matrix. The first defect could be no supply in the power socket. The second defect could be the stabilizer has gone faulty, or maybe they need a stabilizer. The third defect could be there is some kind of a shorting in the power cord, or maybe some wire has gone loose in the power cord. The main PCB could be defective, or except for the spin series, thermal fuse can be defective in the other cases. So these are the various possibilities of failure which are listed down. So now we will start to check each one of these failure modes in their own particular way. The first step that we have to take is to check the power input to the refrigerator. The phase should be to the right, the neutral should be to the left, and the earthing at the top. Neutral to earthing voltage should be 0 ideally, or it can at the most be 2 to 3 volts AC, but not more than that. Phase neutral and phase earth should show somewhere around 230 volts plus or minus 10%. Use a proper multimeter to check these voltages and note it down. If there are any problems, or if there is any voltage which is not ideal voltage, then you may need to ask the customer to install a stabilizer. We have to check the 3-pin plug also, whether there is some wire loose inside the 3-pin plug, so that we know that there is no loose contact in the power input line. So while we are checking the voltages, the phase to earth and phase to neutral voltages should be almost same, but they should never be equal. If we don't find the same voltage as mentioned above, then it would show that the earthing is weak or the earthing is not proper. Likewise, if the voltage between the neutral and the earth is more than 2 volts, we know that there is some fault in the earth circuit which can eventually lead to breakdown of electronic circuits in the refrigerator. If the phase is on the left hand side of the socket, then it would lead to, sometimes it can lead to sensations of current on the body of the product. So there is a chance that people may get a light shock or a mild shock while touching the refrigerator body. Similarly, when we are checking, we should check with a clamp meter to get more accurate results. Just checking it with a tester will not tell us what is the actual voltage that is flowing through the socket. If we have to check the stabilizer, what we have to do is we have to check the output and input of the stabilizer. What is the input to the stabilizer and what is the output from the stabilizer? That would be our first step in checking the stabilizer. This we should do with the help of a proper multimeter, which is set to AC voltage settings. Here we have included a small section where we would be showing the repairing method of a voltage stabilizer, our popular Godrej voltage stabilizer, that is G500X9. When we open the body of the stabilizer, this is what we see. It has a control card, it has a transformer, it has an input and output socket, and it has a display. And you see the AC mains connectors. Red wire is for mains input, blue is for output to the socket. And here to the left you see some brown and black wires in a small connector. These wires are for powering the stabilizer circuit. These wires come from the stabilizer's transformer. They usually carry somewhere around 12 to 15 volts AC. And then you will find two more connectors with a lot of very thin wires. These are the connectors of the display card. In the operating range of the stabilizer, it works between the input voltage range of 130 volts to 280 volts, also 135 volts to 275 volts, and the output voltage range would be 180 volts to 250 volts. So that is the stabilized output voltage which the stabilizer would give. The rated capacity of this stabilizer which we are analyzing is 390 VA, that is 390 volt ampere, with a maximum 1.7 ampere rating at 230 volt AC. And the operating temperature of this stabilizer could be 0 to 50 degrees centigrade. Basically, a stabilizer stabilizes the voltage circuit with the help of a transformer, a power supply circuits, comparators, and a switching circuit. And then we have a display which shows the input voltage, output voltage, and if any error is coming in the stabilizing circuit, then that error is shown, whether it is high voltage or low voltage or any other error that can come in the power circuit. These transformers are used to either convert or transform AC voltage from one level to another. That means it can step up the voltage or it can step down the voltage. The transformer whose output voltage is more than the input voltage is called a step-up transformer, and the transformer whose output voltage is less than the input voltage is called step-down transformer. Transformer primarily consists of a primary winding, a secondary winding, and an iron laminated core. The primary and secondary winding, they don't touch each other. The magnetic field from the primary winding is transferred to the secondary winding through the iron core. This is the diagram which shows how the magnetic field is transferred from the primary to the secondary winding. This is a simple stabilizer circuit. To the left you can see the input voltage and to the right you can see the output voltage. And in between there are shown a lot of transformer windings, and each transformer winding can be switched on and off with the help of multiple relays. So this is the basic and simple circuit of a stabilizer. Now, for example, if the input voltage varies, here the input voltage is varying and it has gone as high as to 80 volts AC. So the comparator inside the stabilizer, it compares the input and the output voltages, and then it switches on the series of relays and which moves the input voltage through that particular transformer winding, which will give the output as somewhere around 250 volts AC. That means here the step down activity of the transformer is taking place through a step down secondary winding. This is how it works. Here you can see the relays, they are switched on automatically so that the output voltage steps down to 250 volts when the input is as high as 280 volts, which is dangerous for the appliance. In the second scenario, the input voltage is 130 volts, but at 130 volts the refrigerator won't work, so you have to step up the voltage to somewhere as high as 180 volts, and this is also done through switching of various relays and by connection of a different set of step up transformer windings to the circuit. All this is done through the comparator, which switches the relays in the switching card and gives the desired output voltage. When the input voltage is in the range of 135 volt to 165 volt, the output voltage range would be 195 volt to 240 volt AC. This is called a boosting circuit or a step up circuit. Similarly, when the input range is 165 to 195 volts, the output voltage will be 195 to 235 volt. This is also a boosting circuit. That means it is increasing the voltage a little bit. When the input voltage is between 195 volts to 240 volts, this is the desired output voltage. So nothing is done in the stabilizer to either step up or step down the voltage, and it passes, let the voltage pass through without any correction or without any modification. So this is the pass through relay. Then the last scenario is when the voltage increases, input voltage increases to 275 volts, then we have to buck or we have to step down the voltage to an acceptable value of 195 volts to 225 volts AC. Here the transformer windings, the various wires that are connected to the transformer are shown. In the stabilizer, all the wires are necessarily connected with a soldered joint, because a soldered joint will be a more robust and it will be a more long lasting joint without giving any loose connections or without giving any sparks. So usually for the stabilizers, soldered joints are preferred. Here the black wire is neutral, yellow is the transformer output, orange is a tapping winding or tapping line, and white is also another tapping line, means the tapping line of two different voltages or two different transformer windings at the secondary side. And the transformer also gives somewhere around 12 to 18 volts AC through a separate set of wires, black, brown and red. Black is neutral, and black and brown would give 9 voltages, and black and red will give 18 volt AC, which is required for the PCB operation. We can check the transformer tappings, the first to last tappings for the output voltages which is given as against the input voltage. We have to measure the input voltage and we have to measure against the neutral black wire. We have to measure each and every output wire, that is white or orange, so that we know what is the output given by the transformer at each tapping. So whether if there is any output missing at a particular tapping, we would know that that circuit or that winding of that transformer, that secondary winding of that transformer is gone bad or it is open. So this is how we can check the transformer output in the stabilizer. And if the transformer is giving the output, that means the transformer is doing its job. But then if there is no output from the output socket of the stabilizer, that means the switching circuit or the main PCB card, it is faulty. If there is no display in the transformer display card, then we have to check the display wires or the connectors whether they are loose or whether there is any rusting, because rusting is resistance. So whatever voltages flow through a wire, if it is rusted, if the joint is rusted, then it will give resistance and it will hinder the flow of current, and thereby it will stop the circuit. So a rusted joint should always be checked for. And also, if the display card or the display cards connector are loose, you can tighten them and you can secure them properly. There is a main fuse in the stabilizer. You have to check the main fuse whether it is blown or whether it is okay, and then when you have to replace it back. Like I said, we have to check the output socket terminal whether there is any loose contact, or if there is no loose contact, we have to check whether a proper output is coming out of the output voltage socket. Whenever the stabilizer is put off because of any error or something, the time delay for restart is 180 seconds. So to avoid restarting of the compressor within 2 minutes of a prior shutoff, smart time delay of 3 minutes comes into play. That means whenever there is a light or a voltage fluctuation which is fluctuating very rapidly, and within 2 minutes if it fluctuates, it comes back to normal, then it goes back to any voltage beyond the range, then to avoid the very abrupt compressor stop and start, this inbuilt delay of 3 minutes, it comes into play, and it helps the compressor from frequently switching on and off. And if the stabilizer restarts after 5 minutes, all this is within 3 minutes. If it starts or stops, then also the stabilizer will start only after 3 minutes, even if the voltage has come back to normal. But if the voltage comes back to normal after 5 minutes, then the stabilizer would automatically start. LC error is for low voltage cutoff. HC error is for high voltage cutoff. If the voltage is lower than 130 volts, then LC, and if the voltage is higher than 280 volts, then HC cutoff will be activated on the stabilizer and it will give that error. When we check the power cord, what we need is, we need some multimeters, we need a tester, we need a screwdriver. The two problems on the power cord is, one is the power cord can be either open or short. So we have to check whether the power cord is open or whether it is short between the phase and the neutral lines. Visual inspection to check whether the insulation of the power cord is cut due to some reason, due to some damage, physical damage. And then we have to check the voltage and the continuity between. First we have to check the continuity between the pin and the wire end at the other end. Each pin, the neutral, phase and the earth, and the neutral phase and the wire the other end. We have to check the continuity to see whether the wires are continuous or whether they are broken somewhere in between. These physical damages could happen because of some object falling on the power cord, or due to insect bite or rat bite, or due to some other reasons. Whenever we see such kind of an insulation breakage, we have to immediately replace the power cord. This method is for testing the continuity.
इस वीडियो में हम देखेंगे पावर कॉर्ड कैसे चेक की जाए। पावर कॉर्ड को चेक करने के लिए हम दो तरीके इस्तेमाल करेंगे। पहला है कंटिन्यूटी मेथड और दूसरा है क्रॉस कंटिन्यूटी मेथड। कंटिन्यूटी मेथड के लिए पहले अपने मल्टीमीटर को कंटिन्यूटी मोड पे लाएं। पावर कॉर्ड के
Keep the multimeter
जो
at
प्लग टॉप है उस
continuity
प्लग
mode
टॉप के हर
and then check
पिन की
each pin with
के
respect to
साथ
the
रिस्पेक्टिव
wire end.
वायर की हम कंटिन्यूटी चेक करेंगे।
Neutral pin with the neutral wire, phase pin with the phase wire, and the earth pin with the earth wire. The continuity
अगर कोई
meter has to
प्रॉब्लम
beep.
रहा तो यहाँ कंटिन्यूटी नहीं दिखाएगी और इसका मतलब है कि हमारा पावर कॉर्ड खराब है। क्रॉस
Then we have to check the thermal fuse. The thermal fuse is a fuse which is given very near to the defrost heater. Just in case the defrost heater is not cut off after defrost and the temperature in that area goes above 70 degrees centigrade, then to avoid burning off and damage of the internal refrigerator parts, the thermal fuse comes into play and it fuses off and it cuts off the 230-volt line to the main PCB or the main control circuit. This thermal fuse, if it is blown off, then the refrigerator will not work and it will not cool. So we have to check whether the thermal fuse has been blown out due to any previous such incident. This is the thermal fuse which is available on the coil. It is installed on the coil near to the heater circuit, and if there is excess ice formation, also we can come to know whether the thermal fuse is not allowing the heater to get on during the defrost cycle. That also can happen. So excess ice formation can also mean that the defrost cycle, even though it is happening, but the heater is not getting on. Heater not getting on could be due to the thermal fuse already blown. Checking the thermal fuse is very easy. You have to check the continuity between the both ends of the thermal fuse, and it should show a continuity if the thermal fuse is intact, or it will show open if the thermal fuse is open. The thermal fuse opens between 68 to 72 degrees centigrade. That means at an average of 70 degrees centigrade, the thermal fuse will blow off and it will get open. The PCB checking for spin kind of refrigerators, we need a very good multimeter for that, because we have to check various voltages in AC and DC. In all spin refrigerators, the basic layout of the control PCB is more or less the same. This is the spin basic PCB, which has got a knob directly mounted on the PCB. This is the spin top PCB. Spin top is that version where you have a set button and you have got some LEDs of different uh, temperature ranges, which is shown at the top of the refrigerator cabinet just above the freezer. And what are the components to be tested? Here we can see there is a 6-pin connector. All these connectors are bunched according to the voltages they emit. All the 12 volts DC connections in the refrigerator are bunched together in the 6-pin connector. All the 5 volt DC connections are in the 4-pin connector. In the 4-pin connector you have two sensors of 2 pins each. That is, one sensor is of the refrigerator or one is of the freezer. And then you have a 6-pin flat connector with 6 small or thin wires which are connecting the main PCB to the display PCB. This is when you have a door display kind of a spin refrigerator, where the display PCB and the main PCB are separated and they are connected through 6 wires or 6 cable straight pin connector. Then you have a 8-pin connector where 4 pins are actually used. 2 pins are phase and neutral incoming voltage, and 1 pin is for phase outgoing to the compressor, and the other pin is for phase outgoing to the heater. The main PCB location. The main PCB location is to the top of the freezer frame. It is behind a small metal strip cover which we have to remove before we are removing the PCB. This is the metal strip which we have to remove, and the PCB box will be found behind it. Okay. So the various components of the spin PCB. This is the transformer. This is the 12 volt DC buzzer. These are the programming pins of the PCB, which is not of any use to us. This is used only by the PCB programmer. And 5 volt DC flat connector. Like I said, for the display they use 5 volt DC, and this is a flat 6-pin connector. And 4-pin 5 volt DC connector, 2 pins each of freezer sensor and refrigerator sensor. Then we have all the 12 volts DC components connected to the 6-pin connector, that is the door switch, the inside lamp of the refrigerator, and the freezer fan. All are running on 12 volts DC. Then we have an 8-pin connector. Like I said, it has an incoming phase and neutral 220 volt AC, and it has an outgoing 220 volt AC for heater and outgoing 220 volt AC for compressor. We also have a thick green color resistor on the main PCB. This is to save the PCB from any high voltages or voltage spike damage. Whenever this resistor is blackened or it is fused out and the rest of the PCB is intact, you know that there is some kind of a high voltage incident which has occurred in the customer's premise. This is the line diagram of the spin refrigerator. Visually check, like I said, if the green resistor has blown, that means the refrigerator has encountered a very high voltage and the customer should be advised to install a voltage stabilizer or a spike guard or both. So here are the various connectors of the spin PCB from where we can check the different outgoing voltages from the main PCB. The first connector is the main incoming connector, 8-pin connector, where brown and blue wires give the phase and the neutral incoming, and a black wire goes out from this connector to the compressor, which gives the phase 230 volt, and a red wire goes out from this connector to the heater, which gives a phase of 230 volt to the heater. Then the next connector is a flat 6-pin connector which goes out to the display PCB. From the main PCB to the display PCB, we have to check 5 volts which is given out from the main PCB. We can check it on the second and third pin of the main PCB where it is labeled as plus 5 volt and ground. Between 5 volt and ground, we have to check for 5 volt DC outgoing voltage to the display. Then the third connector is a 5 volt DC connector which houses two different sensors of 2 pins each, and we have to check the outgoing power supply from the spin PCB to the different sensors. Then we have a 12 volt 6-pin connectors. Here 2 pins each are for the door switch, the LED lamp inside the refrigerator, and the 12 volt DC freezer fan. We can check the voltages going out from the main PCB to these 3 areas from across these 2 pins respectively of each of these 3 outgoing wires. And then here for the fan, the inside and outside leads will give the 12 volts DC outgoing to the fan. Similarly, at the center we have LED inside and outside pins. Between those 2 pins we get 12 volts DC, and to the next side we get the inside and outside pins 12 volt DC which is going out to the door switch. Here is a small video which shows the method of checking the main spin PCB on the refrigerator. Just have a look.
मेन पीसीबी ये फ्रंट में लगी है, ये कवर हटाएंगे और यहाँ से ये हमारी मेन पीसीबी है, और जो हम लोग जैक्स की बात कर रहे थे, ये बड़ा
This is the 8-pin
8 पॉइंट
connector.
जैक है जो सप्लाई को फॉरवर्ड कर रहे हैं। एक फेस है, एक न्यूट्रल है, एक कंप्रेसर के लिए जा रहा है और एक हीटर के लिए। फैन मोटर को सप्लाई ये 6 वाले जैक से है, 21 वाले जैक से है, और सेंसर को सप्लाई जो है वो 4 वाले जैक से। फ्रंट के लिए जो पीसीबी फ्रंट पे लगी है उसके लिए सप्लाई यहाँ से जा रही है। चेक करेंगे, यहाँ पे 5 वोल्ट डीसी दिखेगा, 4.95 वोल्ट डीसी के आसपास दिखेगा। यहाँ पे हम लोग चेक कर रहे हैं फैन मोटर को जाने वाली सप्लाई, नीचे के एलईडी को जाने वाली सप्लाई, करीब करीब 12 वोल्ट डीसी आ रहा है।
Checking the various output voltages
यहाँ
from
पे हम
various
लोग
pins
220
from the
वोल्ट चेक कर
main
सकते
PCB,
हैं।
it will show whether the main PCB is healthy or not.
प्लेन जैक जो फ्लैट वाला जैक लगा है उसमें ग्राउंड और 5 वोल्ट दिख रहा है, वहाँ पे 5 वोल्ट डीसी मिलेगा। फ्रीज़र के लिए जो सेंसर्स गए हैं, यहाँ पे 5 वोल्ट डीसी हम लोगों ने देखा और 4 किलो ओम रेजिस्टेंस हम लोगों ने देखा सेंसर्स का। ये रेजिस्टेंस बढ़ना शुरू हो जाएगा जब ये माइनस में जाएगा, घटना शुरू हो जाएगा जब ये प्लस में जाएगा। उसी तरह से यहाँ पे हम देख रहे हैं 12 वोल्ट 12 वोल्ट 12 वोल्ट डीसी लिखा हुआ है। फैन को सप्लाई जा रही है, एलईडी को सप्लाई जा रही है और डोर स्विच को जा रही है। तो इस तरह से हम लोग आराम से ये पीसीबी चेक कर सकते हैं। मेन पीसीबी
So what are the voltages that we check on this pin PCB? One is the input voltage, line and neutral, 230 volts. Then the supply to the fan, supply to LED and door switch, that is 12 volts DC. Supply to the sensors, 5 volt DC. Supply to the compressor, 230 volt AC. And supply to the heater, 230 volt AC. These are the various voltages that we can directly measure on the main PCB. So this is the item code and the description and the version of various spin PCBs, that is spin top, spin door and spin basic. Next we come to the Vesta PCB. The main PCB location at the back side of the refrigerator, like this, it is inside a enclosure. In the Vesta PCB, you can see there are various terminals. The terminal at the top with the red and black wires, they are for the LEDs, and then to the right of that there is a small connector where you can find the refrigerator and freezer door switch. Then to the right of that, vertically at the top, you can find a connector where refrigerator sensor and freezer sensors are connected, and below that there is an outgoing connector to the display PCB. And then similarly to the left, you can see a big connector with a lot of wires over there. Here from inverter PCB you get the wire connection, you get the heater connection, you get the fan connection, and you get the earthing in sequence number 11. That is, there are so many pins over here and the number of the pins are given across which you can check the connections for various outgoings. In main PCB, you see in that big connector that I showed of 11 pins, pin number 4 and pin number 7, brown and blue wire, 230 volt AC will be coming for the BLDC from the BLDC PCB, and then pin number 2 and pin number 5, it will give the main voltages, that is phase and neutral. Then here at the top, pin number 2 red, pin number 5 black wire, and here at the left, pin number 4 and pin number 7 brown and blue wire. They are the power input to the main PCB, pin number 4 and 7, and at the top, frequency input to the BLDC inverter PCB, pin number 2 and 5. Here at the 11 pin connector, pin number 1 brown wire and pin number 9 blue wire. Between these two wires, if the 230 volts you can see in pin number 1 and 9, then the main PCB is okay. Here for the main PCB to be okay, pin number 1 and 9 should show 230 volt AC between them. And in the same connector, pin number 1 and pin number 9, you see fan output. Here in this connector as shown in the by the red arrow, pin number 3 and pin number 4, 12 volts DC will come in pin number 3 and 4, which will show that the main PCB is okay, otherwise we have to change the PCB. All the LED lights, that is freezer and refrigerator lights, will be on by opening any of the two doors, refrigerator door or the freezer door, as both the door switches are parallelly connected. So pin sequence 3 and 4 are for the 12 volts DC LEDs. Then we come to display. Here 5 volts DC for the door switch coming in pin number 1 and 2 in this connector as shown. If we get 5 volts DC over there in pin number 1 and 2, then that is the main PCB is okay. This is with respect to the door switch. Again showing it in a different way, pin number 1 and 2 in the actual PCB we are showing it. The same thing, door switch which will show 5 volts DC. Here are the various item codes of Eon Vesta 595 MDI and Eon Vesta 485 MDI. Now we come to NXW BMR, that is the bottom mounted refrigerators PCB checking. In the bottom mounted refrigerator, let's look at the PCB and its various different components. Here you see a frequency connection, frequency output and ground. Frequency connections are usually used as a signaling connection. And next to that, to the right at the top, you see freezer LED connections, 12 volts plus and minus, that is 12 volts DC, both the pins you should get if the output has to go to the freezer LED. Then to the right of it, you have the left side and right side connections of the refrigerator LED. Here there are left and right LH and RH LED connections in the NXW for the refrigerator section. In both the connections, you will get 12 volts DC across pin 1 and 3 and pin 2 and 4. There is one small connector over there to the extreme right which is not used. Then we come to the right hand side vertically at the top. The first connector is the display connections, the connections to the display. Then below that we get the connections to the reed switch. What are the reed switch? Here reed switch are the door switches. One door switch for the refrigerator section and one door switch for the freezer trolley. And below that you get the refrigerator and freezer sensor connections. 4-pin connector, 2-pin each for refrigerator and freezer. And below that you have again the reed switch connections, the actual voltages, that is 5 volt to ground and 5 volt to ground. So this is the wiring diagram. So let us see how we check it. Here also there are various pins which are shown. To the left, if you see, pin number 5 is phase, pin number 4 is the heater output, pin number 3 is the compressor output, pin number 1 is the neutral. So pin number 1 and pin number 5 are the phase and neutral incoming, and pin number 4 is the heater outgoing, pin number 3 is the compressor outgoing. This is the white connector, the thick white connector to the left at the bottom. Testing method of compressor output. Here between the neutral and the compressor out, it should show 230 volt AC. That is the test for compressor output. Light not glowing symptoms. What we need is a multimeter. We have a freezer LED connection over there at the top. Pin number 1 and 2, 12 volts DC, because the LED lights in all our refrigerators, they work on 12 volts DC connection. The small connector is for the freezer, and the big connector to the right of it is for the refrigerator section, where I already told that we have two LEDs, one at the left and the one at the right. And at both of it, pin number 1 and 2 will give 12 volts DC, pin number 3 and 4 are ground. So pin number 1 and 3 will give 12 volts DC, and pin number 2 and 4 will give 12 volts DC for both of this left hand side and the right hand side LED of the refrigerator section. If we don't see 12 volt DC coming out from the PCB, then that means the PCB is faulty. And if we can see 12 volts coming here and still the light is not glowing, then the LED bulb must be faulty. So for the freezer and the refrigerator section, here the same thing is shown in a different way. So thank you friends. These are the various methods of how do we diagnose directly on the PCB whether when we check the voltages coming out of the PCB. This is the best method to check any refrigerator with an electronic PCB connection, because at one place on the PCB, at various terminals on the output, you can directly come to know which section is connected to which and whether they are getting the proper voltages, and if they are getting the proper voltages, whether they are glowing or not, or whether they are working or not. So it is very easy to diagnose when you have a multimeter and you have a PCB which is working on the refrigerator. So that use of the multimeter, you can diagnose very fast, because it doesn't take more than 4 to 5 minutes to diagnose the proper problem if we have a multimeter and if we know what to check on which pin and which connections. So thank you friends, until we meet next time with another diagnostic video. Till that time, bye bye.